Hello programmers. So this is the next tutorial in the Coder Specials tutorial series. I believe, what tutorial are we on? I believe we're on tutorial 6. Yeah, tutorial 6. So this will be tutorial 6. And basically this is the precursor to, I'm going to briefly explain to you how to use templates and worksheets in this explanation here. Now, I'm not going to go super in-depth into the code here because this is going to be kind of complicated, and you're only going to fully understand this after a few more tutorials. But what I've done here is I've basically taken the linked list example from a previous tutorial, and then I've modified it to use a pre-designed linked list node class, right? This is a linked list node class that's templated that can accept primitive, struct, and class data types. And the difference I distinguish here is underscore p means that the type here is a primitive. That means like it's an int or float or int pointer or float pointer, something for which you can literally have an instance of it on the stack. Right, so not an array, this doesn't, I didn't write an implementation that would work with a type of array, but it works with base types that are the primitive types and their pointers, and also struct pointers. It'll work if you have a struct pointer here, and so this is the value, right? And this is the pointer to next, right? And this is the implementation for primitive data types. This is the implementation for struct data types, right, that don't have constructors and destructors. And then this is the implementation for classes, that is, structs that have a constructor and destructor. And then here is the worksheet that selects between them. What it does is but we're going to talk about that later. First, I need to show you how it gets used in the program, right? Here we have our head, right? This is the head of the linked list. This will always be occupied, right? This will be malloc in main, right? We malloc it here, and then we call ctor on it. Then we start the program, right? I've modified this so that print list skips the head, and then the head is a dummy, and then the real head of the linked list is immediately after that. The insert and delete, what they do is they just increment the position by 1, and that way they work perfectly, right? Anyway, and what we do is we modify the linked list like this, right? Again, the code is going to be in the description. Let me just show you this works. 0, 12. Insert 0, 13. We're going to insert out position 1, enter a value 7. We're going to insert another value, 39, right? It's going to stick it onto the end of the list here. 555, right? And now we have a few in here. Let's delete some. Delete the one at position 2, right? And as you can see, the one at position 2 was 12. And it went away, and now 555 is at 2. Let's delete the one at position 2 again. This deletes that, right? Let's insert another integer at 0. Enter the value 7. So now we have 7, 13, 7. Let's delete an integer, the one at 0. There, you see this works, right? So this is working, right? And we can continue deleting again and again, right? If we enter an invalid position, it won't work, right? Enter a position 0, and now it's empty, right? And now we can't delete anything more, but we can still insert 444. Yeah, so anyway, this is working. I just needed to demonstrate that this actually works. Anyway, so this is the implementation. You can read this in your own time, but basically this is just, calling methods. This right here, I don't actually demonstrate using the LL node templated class with primitives or with structs, so I briefly demonstrate that, but I don't actually test the functions. I don't know if they work, so you're just going to have to trust me that they might work. I don't know, but I'm just trying to show you the syntax, right? So anyway, I'm going to teach you how to make a templated class, right? Now this might look quite complicated, and in a way it is kind of more complicated than C++, just because we have to differentiate between structs that do not have a constructor or destructor. We need to differentiate from structs that do have a constructor and destructor, and from primitive types. And so we need to basically have 3 separate implementations. Now we could pack this down with macros, right, and remove a lot of the redundancy here, but I tend to just create 3 different implementations when I make these things, right? You could improve this. That's my point, right? So anyway, what we're doing here is we're making this templated type, right? It's the name of the actual type is going to be this right here, right? And basically, here's the code for it, right? We go into global scope. This is so that you can This is an essential thing, right? We need to be able to, right here, define this type in case it hasn't been defined before. We do actually define it up here, so it's not quite an issue, but you know. If this was the very first time that you had ever used this this template, we would need to open a global scope to define the type and the functions and stuff. So we do at global scope. We create the struct, we make the CTOR and DTOR, and then we write the functions, right? And you can, again, read this in your own time. I don't think a linked list implementation is going to be all that important to you. This right here might be of interest to you. This is how we swap when position is 0. This actually never gets used, of course, since we have a dummy head, but, you know, whatever. This is the implementation for structs, right? Again, this is the name of the actual type. We're going to talk about how this gets generated later. Global scope. This ends the global scope. We're going to talk about this later. LL_node_C. This is for structs that have a constructor or destructor. This is the name of the type. You know, we're going to talk about this later. Global scope. End. And then there's this code. And then there's the worksheet. Worksheets, the way that they work is that the first of all, you have to have a huge bracketed portion here, right? You have you have a name, an identifier. Then you have a pair of square brackets. Then there's a fly. Ooh, huge flying thing. Oh my goodness. Some huge flying thing in my room. Okay. Let's forget about the huge flying thing. I'm sorry, guys. I'm afraid of bugs. So anyway, so the way that worksheets work is that they have this outer square brackets, right? Then they have the first set of inner square brackets here, and this contains the code that's going to be pasted in. This is the list of arguments, right? You could have a list of identifiers, right? A, B, C, D, E, F. Any identifiers you want, no commas. And then a bracketed list, and this is the code. This right here is this is the code for the worksheet. The way that a worksheet works is that in this third field here, it gives you this. I believe it's called result, right? Result, CG strl pointer result, right? And what this is this is a pointer to the linked list node type of the tokenizer in the compiler, right? Again, I'm gonna talk in depth about this later. All you really need to know is that in order to transpose this templating system to work with any sort of type that you want, all you need to do is you need to change this piece of text here. You need to change, obviously, this piece of text in all 3 versions, right? P, S, and C. Then in the worksheet, you go through here, you change these from LL_node_P and C to whatever type _P_C, or however your naming convention is. Then in here, you should replace this text here to refer to the type you're talking about here. these need to be replaced. Yeah, and I think that's about it. Oh, yes, right, and this thing, right? This is error text that will print on the command line if there's an error. So you should replace this. This should be an identifier, and you need to replace these. Yeah, and that's about it. So anyway, that's how you do that, and that's how worksheets work, and that's how templates work. Now this, again, I realize this would be quite confusing. This is an extremely advanced topic, but I thought I would just show this off. Now I will confess that this is quite terse. This system for templating, the way that I've implemented it is quite terse, and a huge part of that is my fault. I haven't put all this stuff into functions to make it easy. I've also, I haven't written helpers to make writing code that is the same for structs, primitives, and classes easy, right? So because of the primitive state of my tooling, the templating system is kind of bad, right? It works really well. It's very precise. It actually is more precise and I think it's actually more useful than C++'s templating system, but it's just kind of verbose. And when you want to do simple templating like C++ templating, this ends up being a little harder to use. But this is how you do it, right? And the reason I wanted to make a tutorial about this, the reason I don't just dive headfirst into talking about CodeGen code and the structure of the compiler, is that I wanted to... Okay, there's that bug. I got it, I think. Did I get it? Oh no, it got away, I think. Yeah, it got away. Fuck. Horrible insect. It was a moth, not a fly. Anyway, fucking moths. I hate those things. Anyway, so this is a cute little demo of how to use templates and worksheets, right, together to create a templated type. And this is the result. We have this templated LL node type that can accept a primitive. It can accept even one of its own, right, which this is a class. And it can even accept a struct, right, a normal struct. And so that's the result, right? Now, again, as I said before, only the version that works for primitives has been tested. But the version that works with structs and the version that works with classes should also be fine, right? This type here would work with classes. This one would also work with classes. This would be a type that works with primitives. This would be a type that works with a struct that does not have a constructor or destructor. Yeah. I admit that this isn't very much of a tutorial. I'm not exactly teaching you very much in my speech, right? I'm just hoping that you're going to be able to read this code and figure out what it's doing. You don't really have to understand anything that this is doing other than, this piece of text right here is being basically extended with an integer right here that is being written onto the end of this thing. And then we replace every instance of this with the integer on the end, right? And that's all that's doing, right? And it's going through the entire this thing, and it's doing that, right? And when all is said and done, this thing right here, this is what's going to be pasted in. Here, right? At this point in the code, right here, what's going to be pasted in is the identifier created by turning this thing into this with this integer on the end, right? And by the way, notice the structure here. We have this special bracketed thing with the replacement magic right here. The templating system looks for a bracketed argument list, and this is what anything inside these brackets is going to be pasted in right there, right? So let's actually type a bunch of question marks, right? Not in the C one, let's do it in the P one, just to show you that that's what's happening. This is going to not work. Identifier required in global variable declaration, LLD, right? So it's trying to declare a global variable, right? Because it's trying to do it right here. but we have a question mark right there on column 38, right? That's this question mark, right? So this anything inside these brackets is going to be pasted in here, right? So that's how that works. I hope you guys enjoyed, and I realize this is a complex example. I encourage you to study this. When we talk about the CodeGen code in depth, and when I talk about how a make template was written and how it was designed, you're going to understand better how this works. You might even be able to make a better templating system than I did. A lot of the stuff that I've written for Coder's Basilisk, I've realized has been a little bit terse, a little bit janky, a little bit wonky. I've been focusing more on the theory and less on the praxis of tooling. And so tools like make template here are not quite as refined as they could be, right? It's not a weakness of Coder's Basilisk, it's a weakness of my tooling of it. I hope you guys enjoyed. Thanks for watching.